Introduction. Python is a popular programming language. It was created by Guido van Rossum and released in 1991. Python can be used on a server to create web applications, alongside software to create workflows, to connect to database systems, to handle large amounts of data and perform complex mathematical operations, for software development. You have already learned some basic commands of Python in the previous classes. Let us learn about some more commands in this lesson. Cool fact: Python is one of the official languages at Google. Taking input in Python. While creating a program, we often need to interact with users either to get data or to provide some sort of result. Most programs today use a dialog box as a way of asking some type of input from user. Python provides us with inbuilt functions to read the input from the keyboard. The input function, prompt. The input function first takes input from the user and then evaluates the expression, which means Python automatically identifies whether the user entered a string, a number, or a list. If the input provided is not correct, then either syntax error or an exception is raised by Python. Example: output. Working of the input function. When the input function starts its execution, the program flow stops until the user gives an input. The text or message displayed on the output screen to ask a user to enter the input value is optional. This means that the system will wait for the input from the user, but if a message is not given in the program, there will be no physical indication of what is being expected from the user. Whatever you enter as input, the input function converts it into a string. Even if you enter an integer value, the input function converts it into a string. You need to convert it into an integer in your code using a particular command. Decision-making statements in Python. There are situations in real life when we need to make some decisions, and based on these decisions, we decide what is to be done next. Similar situations arise in programming also, where we need to make some decisions, and based on these decisions, we will execute the next block of code. Decision-making statements in programming languages decide the direction of flow of program execution. The following are the decision-making statements available in Python: if statement, if-else statement, nested if statement, if-else if statement. If statement. The if statement is the most simple decision-making statement. It is used to decide whether a certain statement or block of statements will be executed or not. That is, if a certain condition is true, then a block of statements is executed, otherwise not. Syntax. If condition. Hash statements to execute if condition is true. Here, the condition after evaluation will be either true or false. If the statement accepts Boolean values, if the value is true, then it will execute the block of statements below it, otherwise not. We can use the condition with brackets also. As we know, Python uses indentation to identify a block. So, the block under an if statement will be identified as shown in the following example. Test expression, false, statement just below if, true, body of if, statement just below if. Example. Output. If-else statement. The if statement tells us that if a condition is true, it will execute a block of statements. And if the condition is false, it won't. But what if we want to do something else if the condition is false? This is where the else statement comes in. We can use the else statement with the if statement to execute a block of code when the condition is false. Syntax: if condition, hash executes this block if condition is true, else hash executes this block if condition is false. Start, test expression, true, body of if, stop. False, body of else, stop. Example, output. Nested if. A nested if statement is an if statement that is the target of another if statement. Nested if statements means an if statement inside another if statement. Python allows us to nest if statements within if statements. That is, we can place an if statement inside another if statement. Syntax: if condition 1, hash executes when condition 1 is true. If condition 2, hash executes when condition 2 is true. Hash if block is end here. Hash if block is end here. Start, if condition, false, nested if condition. Nested if body. Nested else body, statement just below if. Exit, true, if body, statement just below if. Exit. Example, output. If elif else statement. Here, a user can decide among multiple options. The if statements are executed from the top down. As soon as one of the conditions controlling the if is true, the statement associated with that if is executed and the rest of the ladder is bypassed. If none of the conditions is true, then the final else statement will be executed. Syntax: if condition, statement, elif condition, statement, else statement. Start, condition 1, true, statement 1, next. False, condition 2, true, statement 2. Condition n, true, statement n, next. False, statement 3, next. Example, output. Loops in Python. Python provides 3 ways for executing the loops. While all the ways provide similar basic functionality, they differ in their syntax and condition checking time. While loop. In Python, the while loop is used to execute a block of statements repeatedly until a given condition is satisfied. And when the condition becomes false, the line immediately after the loop in the program is executed. Syntax: while expression, statement, or statements. All the statements indented by the same number of character spaces after a programming construct are considered to be part of a single block of code. Python uses indentation as its method of grouping statements. Example, output. For loop. The for loop is used for iterating, repeating over a sequence. This is less like the for keyword in other programming languages like C. It works more like an iterator method as found in other object-oriented programming languages. Syntax: for iterator underscore var in sequence. Statement or statements. Example, output. Infinite loop. While using a while loop, if you forget to increment the counter variable in Python or write a faulty logic, the condition may never become false. In such a case, the loop will run infinitely, and the conditions after the loop will never be executed. To stop execution, press Ctrl+C. However, an infinite loop may actually be useful for cases when a semaphore is needed, or for client or server programming. A semaphore is a variable used solely for synchronization in accessing shared resources. Example: output. It will show hello world for an infinite number of times. Nested for loop. You can also nest a loop inside another loop. You can put a for loop inside a while, or a while inside a for inside a for, or a while inside a while. Or you can put a loop inside a loop inside a loop. You can go as far as you want. Example: output. Loop control statements. Loop control statements change execution from their normal sequence. When execution leaves a single block of code, all automatic objects that were created in that block are destroyed. Python supports the following control statements. Break statement. When you put a break statement in the body of a loop, the loop stops executing and control shifts to the first statement outside it. You can put it in a for or while loop. Example: output. Continue statement. When the program control reaches the continue statement, it skips the statements after continue. It then shifts to the next item in the sequence and executes the block of code for it. You can use it with both the for and while loops. Example: output. Pass statement. When we need a particular loop, class, or function in our program but don't know what goes in it, we place the pass statement in it. It is a null statement which, when executed, leads to nothing. The interpreter does not ignore it, but it performs a no operation, NOP. Example: output. Keyboard shortcuts used in Python. Keyboard shortcut: command operation, description. Ctrl+T creates work area. Creates a tab in the work area of the Python editor for the new script. Ctrl+O loads script. Loads the selected script in the Python editor work area. Ctrl+- closes script. Closes the active script in the Python editor work area. Ctrl+S saves active script. Saves the active script. Ctrl+F2 saves new active script. Saves the new active script. F5 executes active script. Executes code or a script depending on whether code is highlighted. If nothing is highlighted, it executes the active script in the Python editor work area.